Hello and welcome to Web Math Academy, where this week we're going to continue our study of complex numbers. Now, for all applications that call for raising a complex number to a power or finding the roots of a complex number, we can use Demoivre's theorem, named after the mathematician Abraham Demoivre. Basically, to raise the complex number to the power n, you simply raise the modulus r to the power n and multiply n times the argument theta for cosine and I sine. Let's try this with an example that we had used last week, 3 plus 4i, and raise it to the third power. You remember from last week that 3 plus 4i in polar coordinates equals 5 times cosine 53.13 degrees plus I sine 53.13 degrees. So here we have r equals 5 and n, the power we're raising it to, 3. So if we use Demoivre's theorem and follow this mathematics here, we come up with 125 at 159.39 degrees. We can use our TI-Nspire calculator to verify this. Now the calculator works in both rectangular coordinates and polar coordinates, so let's try rectangular first. We'll put the parentheses in, 3 plus 4, and then I. Right parentheses, raise it to third power, and enter. And that is the exact answer in rectangular coordinates. Now if we try this again in polar coordinates, same thing, left parenthesis, and 5, 53.13, right parentheses, raise to the third, enter, and it gives us the same number again in rectangular coordinates, which we can then convert to polar coordinates very easily. And menu, number, complex number, and convert to polar. Enter. And the answer there you'll see is the exact same answer we have on the right here, 125 at an angle of 159.39 degrees. So you see you can use your TI-Nspire calculator for any complex number calculations. Now on to roots. Roots are a little bit trickier, namely for the reason that there is more than one answer. Square roots have 2 solutions, cube roots 3 solutions, and so forth. Let's try a straightforward example and compute the square roots of -1. Here r, the modulus, equals 1, and n, since we're squaring it, is to the 1/2 power, and we should expect 2 roots. So first we rewrite -1 in polar form. You see it's in the red equation here, -1 equals 1 cosine 180 plus I sine 180. Now we can check this to make sure we have the right formula. If we replace cosine 180 with -1 and sine 180 for 0 and follow this through, you'll have -1. So we can use Demoivre's theorem to find this root, and in this case we're going to raise the modulus to the power 1/2, and we're going to multiply the power 1/2 times the argument, or the theta, the angle. When we do that, we come up with cosine 90 plus I sine 90, and since cosine 90 is 0 and I sine 90 is 1, we're left with I as the root. To get the second root, we simply add 360 degrees to 180 and start all over again. So when we add 360 to 180, we end up with 540. So if we raise the modulus r1 to the 1/2 power, that's 1, and cosine 270 plus I sine 270, that leaves us with 0 minus I, which equals -I. So the roots of the square root of -1 are both I and -I. For higher order roots, you simply continue to add 360 over and over again and recompute until you have the n number of roots. Now let's try another one. Let's try the cube root of the complex number 1 minus I. Now first we rewrite that in polar form, and that comes to the square root of 2 times the cosine of -45 plus I times the sine -45. We can check to make sure that this is correct by replacing cosine -45 with square root of 2 over 2 and I sine -45 with minus square root of 2 over 2. When we multiply that out, we come up with 1 minus I. Now, using the rule of powers, the cube root of the square root of 2, we actually multiplied those powers together to come up with the sixth root of 2. So that using Demoivre's theorem, cube root of 1 minus I equals the sixth root of 2 times cosine negative 1/3 times 45 plus I sine negative 1/3 times 45. Negative 45 over 3 is simply minus 15, and sine minus 15. If we calculate those values and multiply by the sixth root of 2, we come up with our solution, 1.08422 minus 0.29051I. Now, to come up with the other two solutions, we just add 360 degrees to the value of 45 over 3. So in that case, we come up with the cosine of 105 plus I times the sine of 105. And when we multiply those out, we come up with the answer 0.29051 plus 1.08422I. We continue on with the third and final solution, and we come up with negative 0.79370 plus negative 0.79370I. Now we could continue adding 360 to keep getting more solutions, but all you would come up with is these same three solutions repeated. Let's use our TI-Nspire calculator to graph these results. To begin, we have to determine whether or not we're going to use a graphing scratchpad or a graphing document. In this case, we're going to want to use a graphing document because it contains some extra features that the scratchpad doesn't. So to open the graphing document, go over to our calculator, hit on, and then click on the graphing icon. So the first thing we want to do is change the zoom level, and that's easy to do. You just go to Menu, Windows Zoom, zoom in, and click twice on your center button. That should be good right there. Now we can start plotting our coordinates. To do that, it's Menu again, Geometry, and this, by the way, is not included in the scratchpad, Points and Lines, and Points by Coordinates. And we can put in our first coordinates. We'll use 1.08422, enter, minus 0.29051, enter, and there's the point. And the next 2 points are plotted in the same way, and I have those shown for you on the graph here. Minus 0.29051, 1.08422, that's up here, and then down below here is 0.7937 and minus 0.7937. So what I'd like to do next is plot a circle and show that all three of these points lie on the sixth root of 2 circle. So go back over to Menu, Graph Entry Edit, Equation Templates, Circle, we're going to plot a circle, and we're going to use the center form. Okay, since this circle is going to be at the origin, it'll be x minus 0, y minus 0, and here we're going to use our calculator Control caret key, and we're going to put 6 for the sixth root, and then 2. Enter. And you'll see that all three solutions are on the sixth root of 2 circle, and that each of these solutions is 120 degrees apart from each other. So it's kind of cool to see how this works. I hope you have some fun with it and are able to try some of your own solutions. If you have any comments or questions, you can reach us at our website, webmathacademy.com. Thanks.